Invention Disclosure Form for Engineers: What Good Looks Like. Welcome. Today we're demystifying the Invention Disclosure Form, IDF, the first official record of your idea. Filing an IDF helps protect patent rights by documenting what you invented and when, which can be critical in legal timelines. A strong IDF guides reviewers by being clear, complete, and objective, so they can assess patentability and business value quickly. When you draft it well, you save rework, avoid long email threads, and speed decisions on filing strategies. Think of the IDF as your invention's launchpad. The better the launch, the smoother the patent journey. Start by stating the technical problem in plain language. No buzzwords. For example, sensors drift after 48 hours, causing data errors. Then explain the current limitations or pain points. Calibration takes 2 hours, costs overtime, and stops production. Quantify the impact with real measures. Plus 15% downtime. Plus $20,000 per month. Error rate 3%. Stay disciplined. Avoid proposing solutions here. Focus on the need so reviewers understand why solving this matters. A crisp, measurable problem statement sets the stage for patentability and business priority. Now explain what it is and how it works, step by step. Walk the reader through the workflow. Inputs, processing, outputs. Clearly list novel features and contrast them with known methods. Unlike batch calibration, our method uses adaptive thresholds updated in real time. Add variations and optional components you've considered, modes, architectures, or configurations, to broaden coverage. Use consistent terms throughout. Choose controller or module, not both, and avoid marketing language like revolutionary or game-changing. Precision helps reviewers map features to potential claims. Your goal is enablement. Describe enough detail for a skilled person to reproduce the invention. Provide inputs, parameters, and tolerances, ranges, set points, sample rates, acceptable error. Mention materials, tools, or algorithms, libraries, model types, training data size, machining specs. If you reference diagrams or flows, include them, and label steps clearly. State the best mode, your preferred implementation that performs best in practice, such as Kalman filter with Q equals 0.02, R equals 0.5. The more practical and specific you are, the stronger your patent position. List the prior art you know: papers, patents, products, internal solutions. Provide enough detail so a reviewer can find them easily. Then explain how your approach differs: architecture changes, new parameters, unexpected interactions. Highlight unexpected benefits. For example, reduce drift without extra power, or accuracy improves as temperature fluctuates. Be candid about overlaps and limits, what remains the same, where performance degrades, or when assumptions fail. Honest differentiation builds credibility and helps craft defensible claims. Summarize your experiments, tests, or prototypes succinctly. What you tested, how, and why. Report metrics with units and conditions. Mean absolute error 0.8 degrees Celsius at 25 to 45 degrees Celsius. N equals 200, 95% CI. Include edge cases and failure modes. Cold start, noisy sensors, power loss, and note how the system behaves. Attach figures or logs and label them clearly. Axes, units, legends, test IDs. This evidence turns claims into verifiable results, enabling reviewers to judge novelty, utility, and filing strategy with confidence. List all inventors and their specific contributions to the novel concepts. Record dates of conception and reduction to practice. Prototype built or method validated. Note any employer or sponsor obligations, grants, corporate policies, joint development agreements that affect ownership. Flag public disclosures or deadlines, talks, demos, preprints, or marketing releases. These dates can impact patent rights and filing urgency. Clear attribution and timelines reduce disputes and ensure the legal team moves quickly and accurately. Before submitting, confirm the essentials: a clear problem, an enabled solution with build details, and supporting data. Ensure it's distinct from prior art and uses consistent terminology throughout. Make it actionable for reviewers. Unambiguous steps, labeled figures, defined metrics, and known limitations. Finally, include complete attachments and signatures from all inventors and required approvers. If each box is checked, you've created an IDF that is fast to review, strong for patent filing, and aligned with business goals.